All right, now that we have gone through defining our postulate and three theorems, let's work through some examples. Now remember, of our four types of angles, corresponding alternate interior and alternate exterior angles are all congruent when lines are parallel, but your same side interior angles are supplementary. So that one's just going to be a little different. Okay, our goal here is to examine the diagram, determine what kind of angles we're given, and then we can link it back to one of these theorems or postulates to come up with the actual angle measure. So, example 1, find each angle measure. We want to find the measure of ECF. So ECF, I would recommend you put a dot or maybe color that in so you know what you're looking at. The other thing I have to notice is, are my lines parallel? And yeah, they are. I have these marks on my picture. If they're not parallel, none of these properties apply. This only works on parallel lines. So I know that if I can find an angle that is corresponding or is an alternate interior or exterior to the one I have my dot on, then they're congruent. So there's a couple things I see. I see that the 70-degree angle here and the angle I need are corresponding angles, and since my lines are parallel, they are congruent. So I could say the measure of ECF equals 70 degrees, and I'm going to write down y, and I'm going to abbreviate here. I'm going to write the corresponding CORR, use your angle symbol for angles, and then I'm going to write POST for postulate. Okay, that's probably the quickest way. Now, you could have also said, well, it looks like 5x and the angle I want are supplementary because they're a linear pair, and we could have worked with that, but this one's a little quicker. Next one, DEC. So DCE, and I'm going to put a little star right there. Now, one thing I am going to do is, now that I have determined my dot is 70, I'm going to go ahead and add that to the picture because I might be able to use that. Now, when I look at this dot, I see one of two things. I see that 5x and 4x plus 22 are corresponding angles. So I can set those equal to each other. I also, as I told you earlier, I also have a linear pair here. So I'm going to write two methods. I'm going to say we could do 4x plus 22 is equal to 5x, and the reason is because of the corresponding angles postulate. Okay, and I'm going to leave a little bit of space, or I could have said, well, these two are a linear pair, so they're supplementary. I could have done 5x plus 70 equals 180. And I'm just going to write linear pair. Okay, so either way will work. I'll probably just choose to solve the first equation. So I would be taking away 4x from both sides. So that would give me 22 equals x. 22 equals 1x. So I'm done. But I need the measure of DEC. So I keep saying DEC. DCE. DCE is 5x. So I need to plug that in. And so 5 times 22, where do we get there? 22 times 5, we get 110. So the measure of angle DCCE equals 110 degrees. Okay? So we are going to use the property to decide how to write an equation if we need to, and then we're going to work through it. Now, I would like you to try number 1 as secret question number 1. Secret question number 1. Okay? All right, let's move on to another example. Find each angle measure. So letter A here, I'm simply finding the value of x. So you need to examine your picture first. First of all, yes, I have parallel lines because I see my markings right here. So I can apply all of these rules. So you're looking for these 4 types of angles. Or you could work with maybe linear pair vertical angles. So if I want to find the value of x, I've got an x here and an x here. So we have many options. Now, when I look at 2x minus 135 and 70,